Oh, hello. Good afternoon. This is Mr. Precella, and today we're going to be discussing something called square roots. And it's sort of something I'm almost assuming you've seen before in your previous. This isn't like your very first
math class.
Let's see. Problem number 1 says square root of 144. That it says evaluate the square root. Now show my paper, Tim.
Okay.
Oh, by the way, if you hear these names, Tim and Tony, Timothy, Anthony, you calling me Tony earlier.
Oh, I do.
And the students might be wondering, who the heck is Tony? They registered for a Precella. This symbol here is called a radical symbol. And for our purposes today, we're going to read this as square root of 144. Now, what is the square root of 144? Well, what it's asking you is what number can you multiply by itself and get 144? And when you multiply a number by itself, you're squaring it. So do y'all have any idea? Think of the multiplication tables. What number times itself would give you 144?
It's not a trick question.
12?
Okay.
Yeah.
And that's because 12 squared is 144.
Okay. So punch in
Come
12.
over here. Come back here.
Oh, wait.
Oh, no.
No, go to
Wrong
phone.
thing, I know. Yeah. So I'm going to punch in. Oh, suppose I punch in 11 by accident.
Oh, yeah, do that.
Oh, they're going to tell me that's wrong, and they'll give you a little hint there that might help you. Okay. Oh, I'm going to, okay.
You know what? Just 13. That's still wrong. Let's make a good first impression. Get the number 1 completely wrong.
Okay, let's say there.
Oh.
3 mistakes. They're then going to say, okay, you've had your 3 chances to type in the answer. The correct answer should have been 12. I answered 113. Don't go to next question. You want to get the little green check for this problem. That's where you say similar question. For answers that you have to type in yourself, you have 3 chances to type the correct answer. What would I type in for this? The square root of 9. 3, because 3 squared is 9. This time I'll get it correct. And then I can go on. You'll notice something. Notice I had a little red X here for this problem, okay? But now I have the green check. That's what you want. You want the green check? You have it right here on the sidebar. Question 1, you got the green check.
Oh, by the way, Pearson updates the grade as you go through it. Canvas usually syncs pretty fast, but last summer it would not sync. We had to go through and manually sync. So if you start finding yourself, well, wait, I made 100 on that grade on that first assignment, but Canvas doesn't have my 100. Give it time. We'll be looking to see.
Is it syncing? And if not, then every morning I'll get up and just sync all the grades until it starts syncing. You understand what I mean by that? The grade from my lab has to be transferred to the Canvas
wow,
grade
here's
book.
something funny. If our 96-year-old mother were out there, she'd be listening to me thinking, if it's sinking, S-I-N-K-I-N-G, like a ship going down, she'd be so confused. Okay?
Yes,
but,
it would be.
But y'all are 96 years old. So, let's list some numbers whose squares we know. The perfect squares, like 1 times 1 is 1. So the square root of 1 is 1. What are the other perfect squares? 2 times 2, 3 times 3. Well,
what's the next perfect square after 9?
Start calling them out.
These are numbers whose square roots are whole numbers.
4 times 4 is 16. What's 5 times 5? 6 times 6.
What's the next one? 49. I agree. After 49, 64. 8 times 8, I agree. one's saying, so Tony's writing at 9.
9 times 9. 10
That's the
times
next one.
10, that's an easy one. But after that, maybe y'all's numbers, 11 times 11, that's 121. And hey, do y'all know 12 times 12? Yeah, 144. It goes on and on.
Let's keep on going
oh.
until we get to 15 squared. 13 times 13 is
169.
14 times 14. 14 squared is 196.
Yeah. And 15 times 15.
225.
And you see, this goes on, but
Forever, so
Yeah.
we'll just stop at 225. But these are perfect squares. These are the numbers whose square roots can be expressed as whole numbers.
now what about problem 2? Let's do problem
Let's see what
2.
number 2 is.
Square root.
Oh, no.
Oh,
Wrong
two.
things. What did I just do? It was just the syllabus. 2. Oh, wow. Square root of 225.
Y'all remember what that was? Is it 15?
Now, your calculator, what you want is a direct entry calculator. We had a student today email asking if a certain calculator was okay, and the problem is it's not direct entry. You want to do a direct entry calculator will make things much easier for you when it comes time for you to
Punch stuff in. If you want to find there's some calculators, the old-fashioned calculators, when you...
Wait, let me do this. Switch to... That's not an old-fashioned one.
I know, but in the old-fashioned one, if you wanted to punch in the square root of 25,
you have to punch
you
it.
punched in the number and then the square root. You want the type, I think most students like the type, where you punch it in as it's written. Punch in square root, and then what was that, 225? Okay, 15, okay.
Here's the kind that we can get downloaded onto this computer of ours, and it's what, a TI-83 Plus.
And so students say, is that what we're supposed to buy? Well, that's just what we can get.
And
on
have
here.
it downloaded on
This little Casio right here, an FX 115ES, for about $20 or less probably. It does a lot nicer stuff.
Like the TI-36, I think, is another really nice direct entry calculator that's under $20. But if you're using one like this, I know some of y'all have these big graphing calculators because you used them in high school.
Okay, that's fine.
That's fine. Okay, so there you have your square root, 225. You'll notice when I typed in the square root, it opened a parenthesis. That former programmer in me just can't stand dangling parentheses, so I have to close it before I hit enter. And sure enough, it gives me 15. So let's type that answer in. Okay, down we go there. Type in 15. Check answer.
Okay. Next.
Well, they can't all be perfect squares.
Look at number 3. The square root of 18. The square root of 18.
Is 18 a perfect square? No. What you have to ask yourself, what's the biggest perfect square up here that divides evenly into 18? Now, dividing evenly means there's a remainder of what? Does 16 divide evenly into 18?
No.
No.
It's got to have a remainder of 0. So which number? Oh, I wrote 1, but why did I even write that down? I think I said 1 times 1, but we'll never actually do it. Look, 4, 9, 16, 25. Which number here divides evenly into 18? 9. We're going to think of this 18, follow the colors. 9, that's a green square root of 9, times a green square root of 2.
Red square root.
Red square root of 2. Now, let's simplify the square root of 9. That's the green one. What's the square root of 9? 3. The square root of 2 just stays there.
3 times the square root of 2, or you can read it as 3 square roots of 2. Back in the olden days, we would read that as 3 on the square root of 2. But that terminology has been completely removed from textbooks.
Now,
just 3 square roots
punch
of
that
2.
in, Tim.
Okay.
And then,
Okay.
okay,
Wait, okay.
right here.
Okay. Can everyone see that? Do I need to blow it up a little bit? Hold on.
Get rid of
Wait.
that
I
and
am.
make it a little bigger.
I'm going.
There, that's
That
better.
looks better. Okay. So the square root of 18. I click in the blue box. I type the 3. But I need a radical. This thing down here is your toolbar. That's where you go when you're typing special symbols. If you look, I see 2 things that have those little symbols that look like a square root. If you hover over the first one, that says, what does that say? Use your bionic eye. That says square root. Now this thing down here, the second one, that says nth root. That would be something like a cube root or a 4th root. If we were asking ourselves, what can you cube to get yourself 8?
But we're not going to be doing that today.
We're doing square roots. So you click the square root symbol. Now notice the cursor is underneath the radical. What should I type under there? 2. And I check my answer.
Okay. Now, just pull up that TI calculator and type it in and punch in square root of 18.
Okay.
See, this calculator is going to write it as a decimal number. We don't want decimals. There's very few times this semester we'll use decimals. Now, flip over here, Tim. My little cheap Casio. Was it your student or my student? Get rid of that. But I had a student that, they're never going to use this calculator. Okay. They'll never use it again. And so at the end of the semester, the student gave it to my brother. And this is a neat calculator.
I was a little disappointed at the vigor with which she said she never wanted to see that calculator again. It would only have bad memories. She was an A student. Front row, answer all the questions. But she never wanted to see that calculator again.
Now, what do y'all think this calculator is going to give me when I type in square root of 18? 3 square root of 2.
That little cheap, back in the day when Tony and I were in college.
Oh, wow,
something
that
like would have just cost hundreds of dollars.
It didn't exist.
No, it didn't exist.
Okay, number 4. Got to move faster. Square root of 45. Okay, well, it's a bigger number than 18, but is it similar to number 3? Oh, let's see. 45 isn't one of our perfect squares, is it?
What's the biggest perfect square that divides evenly into 45? 9. That's just a coincidence. That doesn't mean your answers for 3 and 4 are going to involve a 9.
Oh, by the way, I remember
coincidence.
one semester a student telling me, this was a few years back, that he couldn't do the homework. And I was like, why? What's going on? And he said, there's something wrong. Because his numbers, when he clicks on it, are not the same problems as mine.
Oh, this isn't a textbook. Your number 5 and my number 5 aren't going to be the same, okay? Every
But they're the
problem
same
is different.
type of
They're
problem.
the same type of problems, but they are not.
But what green number am I going to write? The square root of 9 is 3, and then we still have the square root of 5. So type that in, Tim, to move this a little faster.
But just make sure that you realize that your answers and our answers, occasionally there may be a problem where your number 7 is the same as the number 7 we did. But that's very rare, okay? So realize these answers that we're typing up here, you don't just go home and type in all the answers. You're going to have to do the problems yourself. Remember, I used that square root from the toolbar. There's my 5. Oh, let's see.
Keep going.
Any questions? It just depends on the type of, like this thing here, I can't do that. This one here, if it gives a decimal, you're just stuck with that, okay? We were just making a comparison.
To this calculator,
The small, inexpensive Casio gives the exact value, okay? But
you see,
the big TI gives decimals, and that big TI isn't going to give you the exact value. Okay, so did y'all understand her question? At least I know of no way to take this, what is it? 4 point blah blah, and convert it to exact value.
3 square root of 2.
There's not a key that does that on this TI. Even though this thing costs about $100, and that little Casio cap costs about $20.
Number 5.
The square root of 34.
Huh.
Is 34 a perfect square? No. What's the largest perfect square that divides evenly into 34? And I think you'll agree it has to be smaller than 34.
When we're asking ourselves, what's the largest perfect square? Here's what we're doing mentally. You may not see us doing this, but this is what we're thinking. 34 divided by 4. Does 4 divide evenly into it? No.
I always start at the biggest one and
Does
work my way
9, that
down.
would be better. But 16, 25 sure doesn't divide evenly.
Dividing evenly means there's not that decimal point remaining there. So
have all of the problems had an A and B option, or is this the first one?
So. I think this is the first one.
What do y'all think we should do for this?
Can we reduce the square root of 34? Is there a perfect square that divides evenly into it? No. So it's already reduced. You cannot reduce the square root of 34 any further. So we select option B.
Okay. But they can't all be like that. What's number 6? Square root of...
Square root of 72.
Oh, this is good because...
Well, it's not.
There's several numbers, or 2 of these perfect squares divide evenly into 72.
Well, first of all, do y'all agree 72 is not a perfect square? It's not up there on our list. What's the biggest number that divides evenly into 72?
Like this.
9 times 8. 9 goes in evenly. But is there a bigger one?
It's not going.
Okay.
I think I might have heard 36.
Okay.
No,
Oh, yeah, that's what I pull it up.
All
So, 72. Okay, I'll start with the number that's
Smaller
the biggest number that's smaller than 72. Well, 64, obviously, there's going to be a remainder there. 72 divided by 49, another. Yeah, there's a remainder. 72 divided by 36, what happens? There it is.
36 times 2 is 72. So the square root of 36, what green number am I going to write? 6. Good. And then the square root of 2.
When a square root is in reduced form, there cannot be another perfect square divisor for the number that's under the radical. 2 and 5. There's no perfect square that's going to divide evenly into 2 or 5. You say, well, let's try using 9 times 8. If you had tried this, don't write it down. If you had said, well, the square root of 72, that's a square root of 9 times the square root of 8. The square root of 9 is 3. Now 8, is there a perfect square that divides evenly into 8? I think there is. What number up here divides evenly into 8? 4. That cannot be right. You cannot have a perfect square divisor for the number under the radical. 8 is divisible by 4.
number.
That's why you have to use the biggest perfect square that divides evenly. 9 divides evenly into 72, but there's a bigger one. 36. That's the one you have to use. And the answer they're going to want is 6 square roots of 2. So we come over, we'll punch in 6 square roots of 2. Any questions there? Oh, another square root. This time the square root of 20. The square root of 20. Is 20 a perfect square? No. What's the biggest perfect square up here that divides evenly into 20? I couldn't hear you. No, I don't think 9 goes in evenly. I think
4.
there is.
Yeah, it's going to have to be 4. 4 times what?
If you went 16, notice there's a remainder, that decimal. If you went 9, there's that remainder. I think it's a 4.
So call it out. What blue number am I going to write? 2. And then the red square root of 5. It'll stay. So 2 square root of 5. Oh, wow, Tim.
Any questions there?
This rate, we're going to be finished before you know it.
Now we have some longer problems coming up, Tony. So. Any questions?
When do y'all think y'all will remember this stuff the best? Like as soon as the class ends, or maybe wait a month or 2 and then try to remember how to do this?
Or let's see, it's due on September 2nd on Saturday, so maybe wait until Saturday night to do it. You think you'll remember all this real good then? As soon as you have a chance, do your math homework, okay? So, I understand the point Tony's trying to make.
Poorly,
but okay. The square root of 360. Hey, it's 360 before. Look at that. Is that a square, perfect square? Let's see. Maybe it is. No. If it were a perfect square, it would have that 0.9 blah blah blah. It'd just be an integer. So it's not a perfect square. What's the biggest perfect square that divides evenly into 360?
Well, there's one that just sort of stands out to me. Since it ends in a 0, what am I thinking? 36 times 10? Now, how do I know if this is the biggest? Well,
10. Okay, come up here. Find the number smaller than 10. Will 9 divide evenly into 10? Can you go 10 divided by 9 and get an integer?
nope.
No, that's going to be a 1 point something. What about 10 divided by 4? Is that going to give you an integer? No, that gives you a 2.5. So there's no perfect square that divides evenly into 10. But 36 is a perfect square. The square root of 36 we can express as 6
square root of 10. So 6 square root of 10.
The largest perfect square that divides evenly into 360 is 36. Any questions there? I think we're going to get some longer problems eventually.
Well, that's
6
getting longer.
square roots of 10. Is that right? Yes, it is. Any questions? A square root of 50.
Oh, we haven't done that one? No, okay.
Square root of 50. Is 50 a perfect square? No. What's the largest perfect square that divides evenly into 50? 25. You're thinking 25 times 2. Okay.
Good.
The square root of 25 is 5. What happens to the 2? Stays under the square root. Good.
Square root of 2.
For 5 square roots of 2. 5 square root 6 5 square root 2.
Oh, square root of
Square root of 208.
Huh.
Is that a perfect square? No?
No, because we listed them out through 225,
and
so it wasn't listed there.
so 208.
Oh gosh.
Well, let's see. I think we can tell clearly that 196 wouldn't go in evenly. 169 wouldn't. 144, no. Let's see. 208 divided by, divided by 121. I'm just going through in my head. So 81, no. 208 divided by 64. No. 208 divided by 49.
Y'all see what he's doing, getting these.
I'm trying to show my thought process. I'll be honest, I'm real good at doing arithmetic in my head. I don't have to punch this 208 divided by 49 into a calculator to realize I'm going to get a decimal part. Okay?
But your job isn't to
just get the
answer.
My job is to hopefully try to explain to you my thought process.
Okay. My goodness. Is this one that doesn't have an answer?
I think it does.
It does? Oh,
I
okay.
think so.
Oh, there it is. 16 times 13.
208 divided by 16. Well, 4 goes in evenly also, but if you use 4, you'd wind up with a 52 under the radical. 52 has a perfect divisor, a perfect factor of 4. So,
To write it like this, what green number am I about to write? 4 and a square root of 13.
realize that the 13, there's no perfect square.
Oh, my battery went dead, Tim. How long has my little thing not worked?
Well, we haven't used them since last summer, last spring.
But it showed 5 batteries.
Oh, that means nothing.
Oh, okay. Let's see if this works.
It worked earlier.
Mm-hmm.
So, notice 13. 9 doesn't divide evenly into 13. 4 doesn't. There's no perfect square factors of 13. That's why it's okay to leave 13 under the radical. So, have someone ask me, I thought you could have a big number under a radical. Sure you can. 13. There's no perfect square factors of 13.
So, punch that in. And let's do number 11.
So 4 square roots of 13. Any questions there?
This college algebra and yes, okay. Hey,
Sign in.
there's sign-in sheets there if you want to see if your name. By the way, before y'all leave today, make sure you signed out beside your name on one of those roll sheets. If your name isn't there, you've got to tell us.
It'll only be on one of the roll sheets, though. Okay.
Square root of 90. By the way, this I guess what is listed on your schedule first? The foundations course and then the college algebra? Is that how y'all get listed? The 2 o'clock class is the foundations. For us, it's just all merged together starting at 2. And usually we'll get out, well, before 4:50. Let me see how we're doing. All right. Okay, square root of 90.
Is 90 a perfect square? No. What's the largest perfect square that divides evenly into 90?
I'm thinking
that's 9.
Yep.
I think you're right.
9 times 10. So I will have a green 3 and then a red square root of 10.
Any questions there?
Sometimes students say, oh, wow, do I have to do all that writing? I can get that answer. I can go from here to here without that. And my answer is always, your goal and mine are different. Your goal is to get the answer as quickly as the correct answer as quickly as possible. Without cheating, using photo math, using your genius friend or whatever.
Using your chat GPT or
whatever. Okay, your answer is to your goal is to honestly get the correct answer as quickly as possible in an honest fashion. My goal is to try to show you how to do it. Your goal and mine are different. So do you have to show everything I show? No.
3 square root 10.
Finally, a different type of problem.
To multiply square roots, you keep the same square root, you just multiply the radicands, the things underneath the radical.
What is that? Square root of 3
times the square root of 21.
Times the square root of 21. Okay, the square root of 3 times the square root of 21. We're doing a different problem now. The first 11 problems with simplifying square roots. They can't see it because the first 11 problems we were simplifying square roots. Now we're starting to multiply square roots. To multiply square roots, you just keep that square root symbol and then multiply the 3 times 21. What's 3 times 21? 63.
Is 63 a perfect square?
You always got to make sure that the square roots you're writing are simplified. Is there a perfect square that divides evenly into 63?
I think there is.
What's 9?
9 times 7.
So this is one of the things that people might consider difficult about math, the way it builds.
7.
Oops, 7. Where'd I get a... You know what I'm going to do? I'm going to come up. I messed up there. So I'm going to just write here. Square root of 9. And then a red square root of 7. I did it right that time. Thanks. Y'all don't have an identical twin sitting right beside you correcting your mistakes, do you? And if you do, you're not supposed to let them do that on the test, okay? On the homework, yes, but not on the test. Okay.
Okay.
Square root of 9. What green number am I writing? 3.
Square root of 7 stays as is.
So 3 square root of 7. In general, let's switch. I'll write for a while.
Oh, okay. Good.
In general, we can say that the square root of A times the square root of B, you keep the same square root symbol, you just multiply the radicands, A times B. Now that sounds painless, except then you got to still simplify it. Okay, real carefully, a little word about these little ones that it looks like my brother's drawing here. Oh, you haven't been closing your square roots, have you? No, I broke that habit years ago. We had a teacher in, 7th, 8th grade, that told us to put this little mark to indicate where you were closing the square root. And it took me years and years to break that habit. I'm not even trying to break that habit. That isn't a 1. It's just a little hook closing the square root. You know, doesn't it? It doesn't look like it to me. Well, how many times have y'all ever seen someone writing a little hook like that? Never? Okay. Let's go on to the next one. Oh, did we punch in the right answer there? Oh, I don't remember. 3 square root of 7. 3 square root of 7. But your hook is the equivalent of the little blue box. Okay? Saying, okay, that's closing it.
Okay. Okay.
Oh, wow.
Okay, number 13. Let me write it down. The square root of 23 times the square root of 23.
Huh.
Switch over.
Okay. I'm going to go ahead and punch in 23 times 23.
Using our property of multiplying square roots, we know that's the square root of 23 times 23. But I don't know what 23 times 23 is, do I?
529.
That's 529. Is 529 a perfect square?
And if so, what's the square root of 529?
What do you square to give yourself 529? What times itself gives you 529?
This is a question that seems difficult, but it's only because it's so obvious. If you look at where my mouse is, it's, what am I trying to say with this?
23.
23.
Or you could punch it into your calculator to verify.
What's the square root of 529? Is it 23? Well, it better be.
It better be.
Right there, 23 times 23. I'm wondering if y'all could figure out a rule to go from here to there.
Come back to, okay, here I have an A and a B. We're going to write a new rule. The square root of A times the square root of A. So as you have the same thing under the radical, the square root of A times the square root of A
Could y'all tell them?
equals A. A for anything. The square root of anything times the square root of that same number. You just drop the square root and you have that radicand. Now, there's another way of expressing multiplication by itself. The square root times itself, that's the same thing as saying the square root of A squared. The square root of A times the square root of A, that's the same thing as the exponent square. And that's going to be important come the next homework assignment.
In fact, I think it follows this throughout the whole semester pretty much.
Yeah.
Okay? A square root times itself or a square root squared, those just cancel out. And if you're thinking, oh, I don't understand why, use a smaller number. Can pretend number 13, the square root of 5 times the square root of 5. I think that
the square root of 5 times the square root of 5. Well, you know that's going to be the square root of 5 times 5 is 25.
Now, is it obvious why the answer here is, what's the square root of 25?
5. Yeah, that would have been a better problem rather than 13. But the way the numbers are generated randomly, we got stuck with the 23 on number 13. I have a colleague that doesn't like this program because they can't control the numbers. Yeah, that's right. I have no control over what numbers they give me. And when we start getting some messy things to factor, I can't sit at home and work out all the problems in advance to make sure I know how to factor them real easily. Can't do that. Not with my math lab, because when I go and log in again the next time, guess what? They'll give me different numbers.
Okay, well, enough
let's keep going.
But that little rule about a square root times itself, that's going to be important in the next lesson.
Number 14, the square root of 5 times the square root of 10. Okay. The square root of 5 times the square root of 10. You're getting ahead of me, okay? So, 5 times 10 is 50. And then I would have asked, is 50 a perfect square? And y'all would have said no.
They would have looked at number 9.
Looking at number 9. We already reduced the square root of 50, haven't we? The square root of 50, we used a 25 and a 2. Times the square root of 2. And the square root of 25 is 5. The 2 stays under the square root symbol.
They're writing, and they finished it a long time ago.
There.
Okay, so 5 square root of 2. Yeah, demonstrating how this stuff just builds.
Oh, but look. Okay, you'll notice we got the little green check here. And if we stop doing the homework right now, we'd have a 73.91 on it, okay? Well, you got to get an 80 to go on, so keep on going. But the point is, my math lab is updating its own grade book as you go through answering the questions.
But Canvas might not
Canvas won't update that quickly, okay? But it will update, and if it doesn't, we'll be watching, and
if you get nervous, you can email us and say, or
it's
ask
not
us,
updating, and
we'll look and see. It's just not.
adding and subtracting radicals. We know how to multiply radicals, okay? That's what we were just doing. You just keep the same radical part and you multiply the things underneath them. To add, oh, maybe we should.
Here's something we did a year ago. Let's do that. Let's review a phrase called combining like terms. Do you remember that phrase, combining like terms? A previous teacher would have used it.
Probably one of the first things you would have done if you took math 0371.
The developmental math, or even high school algebra 1. That's one of the first things. Let's do 3x plus 6x.
Like terms have to have the same variable part. If there are any exponents, has to have the same exponents also. But if we had something like 3x plus 5x, first thing you do is you notice like terms have the same variable parts, x and x. So to add or subtract them, you keep the same part, the variable part. You add or subtract the numbers in front. What do you call the number in front of a variable? Who remembers that? You have the variable, the number in front is, it starts with a C.
Coefficient.
Coefficient. 3 plus 5 is 8.
So when you say 3x plus 5x is 8x, that's the equivalent of saying 3 cats plus 5 cats is 8 cats. Okay? Now,
adding and subtracting square roots is the same as combining like terms. You must have the same radical part. You have to have to add or subtract square roots you must have the same radical part. You can't have a square root of 2 added to a square root of 3. You have to have the same things under the square root. Maybe I should write it like that rather than saying like square like.
The same.
You must have the same
numbers under the square root.
Numbers under the square roots. And if you do, then it's not combining like terms. You have the same square roots, the same numbers under the square root. You keep that square root. You add or subtract the coefficient. For the lack of anything better, I'm going to call the number in front of a square root the coefficient. 5 is the coefficient for the square root of 2.
Now, before they think this has gotten really, really hard, let's go ahead and do number 15.
Yes. Probably I should have just gone straight into the example.
Maybe that would have been easier for them. Okay. We have 6 square roots of 6 plus 7 square roots of 6. To add or subtract square roots, you have to have the same radical parts. So you have to have the square root of 6, the square root of 6. You can't have a square root of 5 and a square root of 6 there. Unfortunately, we do have the same square roots. We have 6's under both of them. Can the square root of 6 be simplified? If it can be simplified, we need to. Is there a perfect square that divides evenly into 6? What do y'all think? The only one smaller than 6 is a 4. Does 4 go in evenly? So you can't reduce the square root of 6. So we're going to keep that square root of 6. Now we add the coefficient. 6 plus 7. How many square roots of 6 are we going to have? 13. I think maybe it would have been better just to show them that example. 6 square roots. You were the one. I know. I'm admitting I messed up. 6 square roots of 6 plus 7 square roots of 6 gives us 13 square roots of 6. Do y'all think that a common wrong answer might be 13 square root of 12 or something like that? You don't add the numbers under the square roots. You keep the same radical, you keep the same square root, you add or subtract the coefficient. If that is at 6 minus 7, you'd subtract those. So I'm going to punch in 13 square root of 6. Hey, that's it. We can do this one without any writing. I'll just type it in. 7 square root of y plus 6 square root of y. You have to have the same stuff under the radical. Do we have like radical terms? Is that the same stuff? Yes. So we're going to have a square root of y in our final answer. What are we going to have in front of that square root of y? 13. 7 plus, I don't know why we're getting all these 13s now. 13 square root of y. By the way, when you're typing in the answers, don't hit space keys. There should be no time you have to hit a space. Do not use capital letters. Okay? No caps, no spaces. That can mess up the formatting for how they have it. Oh, now we better write this one down. Yeah, okay, this is number 9 square root of 3 minus 5 square root of 3 plus 4 square root of 3. 9 square root of 3 minus 5 square root of 3 plus 4 square root of 3. Well, here we have 3 terms that are being added. Do we have like radical terms? Yes, they're all square roots of 3. So I'm going to put my square root of 3. I know I'm going to have square root of 3 in my answer. Now, let's combine the coefficients. 9 minus 5 is 4 plus 4 is... So 8 square roots of 3. I can divide it down and I'm not even showing what you were writing down. Here it is. I even went through the effort of using different colors. See, the square root of 3's were like radical terms, so I wrote the square root of 3 down. 9 minus 5 is 4, plus 4 gives me 8. 8 square roots of 3. 8 square root 3. Any questions there? So you must have the same number under those square roots. And if you're thinking to yourself, what the heck are we going to do if there isn't the same? Well, you better be able to simplify the square roots so that you get the same number. Number 18. So number 18 answers the question, what do we do if they don't have the same number? 9 square root of 50 minus 7 square root of 2. But you have to hint in that I've mentioned how everything just builds. You do one thing and it builds.
9 square root of 50 minus 7 square roots of 2. There.
Well, they don't have the same number. So don't get a 48 if you're thinking, oh, 50 minus, I could see the wrong answer, 2 square root of 48, right?
Yeah, if it were a multiple choice, I could see 2 square root of 48 as a wrong answer.
But is there any way we know to rewrite? I'm picking on the one with the bigger number under the square root. If that 50 were a 2, then we could do this. We could subtract them.
Now, do you agree 2 is prime? There's no way you're going to reduce the square root of 2. There's no perfect square that will divide evenly and shrink that 2 down. So it's going to have to be 50. What could we do to get a 2 when dealing with that 50? That square root of 50 has shown up several times. What's the largest perfect square that divides evenly into 50? Down there, that number 9, 25. So you're thinking to yourself, here's what you're thinking. I'm just going to work with this 9 square roots of 50. That's a 9 times, you have the square root of 25 times the square root of 2. What's the square root of 25? 5 times 9 gives me 45 square root of 2.
So did y'all see how we got the 45? That's green square root of 2 became
the green square root of
25 became a green 5 in my mind
times
the 9. That's where we're getting the 45.
But we still have something stuck on here. What have we got stuck here?
The minus 7 square root.
We're just going to see if they were following. Tony.
Okay.
I knew you knew the answer.
Oh.
So now we have 45 square roots of 2 minus 7 square roots of 2. Do we have like radical terms now? Yes. So I put the square root of 2. I'm trying to stop that little hook of mine since it upsets my brother so much.
Oh, wow.
What's the coefficient going to be? Okay, 45 minus 7, I agree with 38. So 38 square roots of 2. If you're trying to add or subtract radical terms that are not like radical terms, you're going to have to either be able to reduce them so that you get radical terms, or else the thing can't be reduced. Did you type in the answer?
Oh. I knew I was getting something.
So the only reason you multiplied the 9 by the 5 was to get rid of the 5 so that we
Yeah,
That's
we
right.
wanted just a number there, and as it stands, it was 9 times 5. All right, so.
But we wanted to get that 2 underneath that first radical.
Mm-hmm. And you might wonder, well, what would have happened if instead of the 50 there'd been a 3, where there was no way you could get it? Well, then it would have been one of those A, B options where you would choose B can't be simplified, okay? But even
Okay,
though
switch
every
over to
problem is
this.
different numbers, if this mine can get an answer on number 18, yours can too. Everyone's number 18, you're going to have to simplify that first square root.
Look, if this had been the problem, can we reduce the square root of 3? Can we reduce the square root of 2? It cannot be simplified.
It can't even be 2 square root of 1.
Division. A square root divided by a square root.
Okay. So he's now starting the last 2 problems.
The first operation we did was multiplication back over here with number, what was it, 12? And then we looked at addition and subtraction of square roots. Now, dividing. For division, we're going to express division using a fraction bar. You have, let's see, I'll say it'll be something with a square root in the bottom. Your goal should be no square root in the denominator. Oh, let's review a little terminology. Remember the top part of a fraction, that's the numerator. The bottom part is the denominator. D for down, it's down under that fraction bar.
Numerator, denominator. If you have a square root in the denominator of a fraction, you're going to have to get rid of it.
Your goal is no square root symbol in denominator. What we'll do then will be to, I want to just write it out. Okay. What we're going to do to eliminate the square root from the denominator of a fraction.
Just the denominator. Or denominator of a fraction is good too.
To eliminate the square root from the denominator of a fraction, and this is assuming that the denominator just has that square root there, okay? There's just a square root term. There's not a 7 plus the square root or a 10 minus the square root. It's just a numerator over a square root. You're going to multiply above and below by the square root in the denominator.
So what he's telling you right now is how you're going to do problems 19 and 20. And you'll recognize those as different from others because up to this point, how many fractions have we had today? I don't think any, right?
Mm-hmm.
Okay, let's look at number 19. Don't panic when you see it. Okay.
Okay. You know, I think I'm going to go to the next page. This is number 19. We have the square root of the fraction 15 over 2. That green is not dark enough in my opinion. 15 over 2.
Well,
we can convince ourselves that to take the square root of a fraction, you have to take the square root of the numerator over the square root of the denominator. And think about this. If I'd wanted, don't write this down, but if I'd wanted the square root of 4 over 9, what would be the square root of 4 over 9? Well, what do you square to give yourself 4? What do you square to give yourself 9? Okay, so you would think of it as the square root of 4 over the square root of 9, which would reduce to 2 over 3. And remember how you multiply fractions. 2/3 times 2/3 would give you back that 4/9. In general, if you have a fraction under a square root, you can rewrite it as the square root of the top, 15, divided by the square root of the bottom, so the square root of 2. The square root of a fraction can be rewritten as the square root of the numerator divided by the square root of the denominator. The logic being the same way we were able to do this. How would you get the square root of 4/9? What do you square to give yourself a 4, a 2? What do you square to give yourself a 9? A 3. Now, we have a 2 down here in the denominator. Is 2 a perfect square? We got to create a perfect square so that denominator disappears. Remember, our goal is to eliminate the square root from the denominator. And remember this little rule we made up here? It had to be important for some reason. Why would I have written it down? If you have a square root and you multiply it by itself, you get a perfect square, so the square root disappears. That's going to be our trick. Oh, where is it? Oh, there it is. We're going to multiply down here by the square root of 2. The square root of 2 times the square root of 2, that's the square root of 4. The square root of 4 reduces to what? 2. So, I'm going to multiply down there by the square root of 2. But you can't just multiply a fraction on the bottom by anything you want. If you want to multiply a fraction, if you want to multiply the denominator of a fraction by something, to maintain the equality, you have to do the same thing to the numerator. Multiply on top by the square root of 2 as well. The square root of 2 divided by itself, any non-zero quantity divided by itself is 1, so we're really just multiplying by the integer 1. You multiply the denominator by the square root of 2, that means you have to multiply the numerator by the square root of 2. We know how to multiply the square root of 15 times the square root of 2. So remember doing that. If you have 2 radicals being multiplied, you keep the radical, you multiply the numbers underneath. So 15 times 2, that's going to give me a 30. The square root of 2 times the square root of 2, you think to yourself, well, that's the square root of 4. That's what you're thinking. And what's the square root of 4? A 2. We should ask ourselves, can the square root of 30 be reduced? No. You look back at your list of perfect squares that we have here. 4, 9, 16, 25, none of those divide evenly. So here is your final answer. Any questions there?
Let's show them your little sentence that you wrote down.
My little sentence? Okay, your goal is to have no square root in the denominator. To eliminate the square root from the denominator of a fraction, multiply above and below by the square root that's in the denominator. Isn't that what we did? The square root that's in the denominator is the square root of 2. We multiplied above and below. That's exactly what we did.
I'll punch that in, and then we'll do another one just to make sure they get the hang of that. We're multiplying. Oh, look at how I'm going to punch this in.
Oh, we're going to have to punch in a fraction.
I'm going to hit this little hot button right here for fraction.
Oh, by the way, notice there's a second fraction bar down here. It's this thing here, a mixed number. If you hover over it, there it says mixed number.
We don't use much mixed numbers in
algebra. Does not lend itself to mixed numbers. I can't imagine you'll ever be using that mixed number hot button. Now let's click up on top. You see it's flashing there. What are we going to type on the numerator? The square root of 30. Then you go down, click in the denominator. What are we going to put there? The 2. You cannot divide that 2 into 30. You can't divide something that's under a square root with something that's not under a square root.
Let's see what this last one looks like. This is problem 20, so it has to be the hardest one that we've done today. 10 square root of 7 divided by 7 square root of 5.
10 square root of 7 divided by...
And this process of getting rid of the square root from the bottom is formally called rationalizing the denominator. Did they use that terminology on number 19? Let's see. Yeah.
rationalize the denominator. That's what
That
we're
means
doing.
remove the square root from the denominator.
What are we going to multiply above and below by here on this? The square root of 5.
The square root of 5, I agree.
Okay, let me-
You multiply by the square root that's in the denominator.
And you might say, well, wait, what about the 7? We're not trying to get rid of the 7, and multiplying by 7 would only give you a 49. It's
You
not going
can,
to get rid of
it's
anything.
perfectly fine to have a square root on top. You just can't have the square root on the bottom of your final answer.
It's also fine to have a 7 on the bottom.
Oh, yeah.
7 ain't under the square root.
Okay. The square root of 5 times the square root of 5 is what? I can't hear you.
Just the square root of 5 times the
Square root of 5 is the square root of 25, which reduces to 5. So here you're thinking to yourself, this thing is 5. You still have to multiply that 5 by what is still down there? The 7. 7 times 5. So our denominator is 35. Did y'all follow my logic there? The square root of 5 times the square root of 5 is just 5. Times that 7, I have a denominator of 35. Up here on top, the square root of 7 times the square root of 5. Is the square root going to disappear the way it did down here? No, because it's not the same number under the square roots. The square root of 7 times the square root of 5 is the square root of 35. You keep the same square root. 7 times 5 is 35.
But
What have we got in front? We still have something. I couldn't hear you. We still have that 10. Remember the way I said here, you can't cancel a common factor with a number under a square root and something that isn't. So you can't cancel those 35s there. But let's look at what's not under the square root. 10 over 35. The fraction 10 over 35. Here's my scratch paper. 10 over 35.
can you reduce that?
I think there's a common factor. You can reduce it by 5. 10 divided by 5 is 2. 35 divided by 5 is 7. So we have 2 on top, the square root of 35, and what have we got on bottom? Not 10, 7. 10 divided by 5 is 2. 35 divided by 5 is 7 for my final answer.
Everyone's number 20 is going to wind up with something like this,
Yeah.
where they have to cancel.
I bet you yours will have, it won't be the same numbers probably, but you'll have something like a 10 over a 25 or an 8 over a 20. You know, there'll be something that you can cancel there.
So 2 square root of 35 all over 7. So I come over here.
What's it going to click first? The fraction bar, okay. And then you have the 2 square root of 35. And what does he do now? Okay, click down there in the denominator and type the 7.
Okay. And let's see. Okay, on Pearson, it's updated immediately. I made 100 on my first assignment. And all of you should try to do the same thing, okay? There's 2 weeks free trial, so you can get started. And what else? Don't get far behind. There was
Don't
something I
get
wanted
far
to mention.
behind.
Oh, well, I'm about to stop recording this, and both of the videos I've made today will be posted on YouTube in a little bit. It's a matter of how fast the internet's going to upload them, okay? Any questions before I stop recording? I'm going to hit